So what's
Yeah,
what
that's fine.
happens next after step 3?
Okay, so then we go on to determine the sign of the torque.
Yeah, we can skip step 4, and step 5 is to determine the sign of the torque.
So if the weight is in the middle, and it's centered in the center of mass here,
Clockwise.
if it's centered, if it's, yeah,
Oh, wait.
if it's centered here,
Yeah.
and your pivot's over here, I mean, logically, I still think it'd go clockwise,
That's right.
so it'd be positive. Okay. Well, what if the pivot were right under there? Then it wouldn't.
Then it wouldn't cause a rotation. Remember that if the force is right on the pivot, you can't cause a rotation. So here it's important that the pivot is not right underneath the center.
Yeah, okay. So yeah, this is clockwise, which will be positive.
Right. So you can see why it's so important here when you draw the force in step 1 to always identify the point of application of the force. Because unless you know where the force is and where the pivot is, you can't tell whether the force is going to give you a clockwise pivot, a clockwise rotation, or a counterclockwise rotation.
Right.
Okay, so here the weight is going to be pushing us clockwise. So that's positive. Good. So that was our step 5. And when you're ready, we can go on to step 6. What's step 6?
And step 6 is to, I always say write the formula because I always have to write my formulas.
Absolutely. What's the formula?
So we write our formula is the magnitude of the torque equals the magnitude of the force times the magnitude of the R perpendicular.
Good.
So that would equal a positive 78.4 newtons times the 2.5 meters.
Good.
So that would equal a positive 196 newton meter.
Good.
Okay. We're still not done with this problem, are we?
No. There's a bunch of steps here. So that gives us that torque, which is, I'll put that in the main picture now, positive 196 Newton meters. All right, so again, we're seeing that for every single force, we have to draw a separate picture to calculate the torque. And we have to know that the weight is always applied at the center of mass of the object. And usually the center of mass is just the center of the object.
Yeah.
Okay,
so
good.
In the definition of the torque, when we think about that, we should think about that as overall torque, or...
Well, no, actually, that's a good question. So this formula here is, these are the formula we're using to find all the individual torques, right? We found one individual torque from the 3 kilograms, one individual torque from the teeter-totter, and one individual torque from the 8 kilograms. This helps you to find the individual torques, and then later you plug that into the net torque equation.
Okay, all right. I won't jump ahead. I just was wondering.
Okay, so...
So now we got...
So there's one more force here that we haven't, that you were mentioning that I haven't put in here. What's the last force?
Pivot.
Yeah, and that's the normal force from the pivot. So that's pointing up like this. This one's going to be a little different than the previous ones. It's going to be a little bit of a trick. So that's our pivot force over there. So, so let's go through the steps for that.
Okay. So that's going to go up. Hold on, I was just drawing a new picture real quick. Let me find our last force. Was 196.